First problem, which is from 1990 AIPMT. In which of the following emission of electrons does not take place? Electrons does not take place. Thermionic emission, thermions are there. Thermions means electrons ejected from a surface by using heat energy. Photoelectric emission, just we studied. Secondary emission, emission means electrons, but in X-rays, no electron is there. It is not ejection of electron. So we will go with option B. So first question, option B was correct. So very simple question they asked, and we have discussed X-ray in electromagnetic waves. Second, just I told you, they asked in a 1998 exam, what are thermions? When you are getting electrons from a matter with the help of heat energy, the name of that electrons are thermions. So we will go with option B. We will go with option B. Third, it is from 2000 AIPMT. Who evaluated the mass of electron indirectly with the help of charge? You know that specific charge means E upon m. It was calculated by Thomson. So in third, for third, we are going with A. 2001 AIPMT. In Thomson mass spectrograph, E is perpendicular to B. Then the velocity of electron beam will be, in your syllabus this experiment is there. So we will go with option A. Now it is fifth problem from 2002. Which of the following is not the property of cathode rays? Cathode rays are fast moving electrons. Any particle which is moving has kinetic energy. If you block that kinetic energy, it will convert into heat energy. So first is the property, it can produce heating effect. Since electrons are charged particle, definitely electric field will put effect on them. So it does not defect in electric field, it is wrong. So we will go with B. It casts shadow, yes. It produces fluorescence, yes. So since it is the not means which is not the property of cathode rays. So since these are fast moving electrons, so they will deflect in electric field. So wrong answer is it does not deflect in electric field. Next, 2003 AIPMT. J.J. Thomson's cathode ray tube experiment demonstrated that A. Cathode rays are streams of negatively charged ions. All the mass of an atom is essentially in the nucleus. The E upon m, just we discussed in first problem. We discussed there this key specific charge E by m. This experiment was done by Thomson's. So we will go with option C. The E upon m means specific charge of electron is much greater than the E upon m of protons. J.J. Thomson showed it. Next, 2006 AIPMT. In a discharge tube, ionization of enclosed gas is produced due to collision between, we know that cathode rays, what are cathode rays which are there? Negative electrons, when they are hitting neutral atoms and molecules, they are showing this effect. So we will go with option C. Next, 2008 AIPMT. In the phenomena of electric discharge tube, through gases at low pressure, the colored glow in the tube appears as the result of collision between the charged particle emitted from the cathode and the atoms of the gas. Yes, we will go with A option because that electrons are hitting the atoms of the gas. So, we will go with option A. Ninth, it is from 1993 AIPMT. The number of ejected photoelectrons increases with increase. You know that if you are changing the wavelength or frequency, you are only changing the energy of moving photons. But if you are increasing the intensity, you are increasing the number of photons, more ejected electrons. So, you can increase the number of ejected electrons with the help of intensity. So, we will go with option A. 10th, it is from 1997 AIPMT. Which one of the following statement is correct? First, the current in a photo cell increases with increasing frequency. No. If you are increasing the frequency, you are only increasing the energy of photon, not number of photons. Photo cell current will increase if you will increase the intensity only. Second, the photo current is proportional to applied voltage. No. If you are increasing the applied voltage, it means you are attracting that photoelectrons. It will increase energy only. The photo current increases with intensity of light. Yes, if we are increasing the intensity, we are increasing the number of photons, means we are increasing the number of photoelectrons. So, we will go with option C. Next, it is from 1999 AIPMT. As the intensity of incident light increases, we discussed if we are increasing the intensity of light, means we are increasing the number of photons, and one photon when hit with one electron, it will throw it out. So, you are increasing the number of photoelectrons, means increasing the photoelectric current. So, as the intensity of incident light increases, photoelectric current will increase. So, we will go with the option A, 11th A. Next, it is from 2001. A photo cell is illuminated by a source of light which is placed at a distance d from the cell. If the distance becomes d by 2, you know that intensity of light is inversely proportional to the square of distance. If you are making distance half, what you are doing with intensity? Orally you can check, but we will do this calculation. It means I is equals to k upon d square. Initially intensity was I1 when distance was d. Now you make the distance d by 2. What will happen to intensity? D by 2 square means d square by 4. What you are getting? One extra 4 in a numerator. It means you are increasing the intensity 4 times. It means 4 times more photons will move toward the metal surface. So, they will eject 4 times more electrons. So, we are going with B. 12th B. 13th, it is from 2001 AIPMT. Which one among the following shows particle nature of light? We discussed कि photoelectric effect established the dual nature of light. Means wave previously it was, but now it behaved like a particle. So, particle nature is defined by photoelectric effect. So we will go with option A. Next, 14th, it is from 2002 AIPMT. When ultraviolet rays are incident on metal plate, then photoelectric effect does not occur. It occurs by incidence of. Actually, for photoelectric effect, we need a minimum frequency which is known as threshold frequency, and you know the frequency of all four waves. We discussed in electromagnetic waves. I gave you one chart. So only it can eject the photoelectrons. X-rays, they are of that frequency. 15th, it is from 2003 AIPMT. A photoelectric cell is illuminated by a point source of light 1 meter away. When the source is shifted to 2 meter, by shifting the source, you are decreasing the intensity, because we know that intensity is directly proportional to distance square. Means intensity is equals to one constant into d square. If initial intensity was I1, what was distance initially? It was 1 meter. Intensity is inversely proportional to d square. Inversely proportional to d square. So what was initial? Initially it was d was 1, it was k. What we did now? Now we make distance 2. So what is intensity now? 2 square means 4. Means 1/4 of previous intensity. It means you are sending now only 1/4 photons towards the metal. So it will decrease the number of photoelectrons by 1/4. So we will go with option first. Each emitted electron carries 1/4 of the initial energy. No, energy is based on only frequency. Number of electrons emitted is half the initial number. No, each emitted electron carries half the initial energy. No, number of electrons emitted is a quarter of the initial number. Yes, 1/4 means quarter. So we are going with D option. Next, it is from 2006 AIPMT. A photocell employs photoelectric effect to convert. What is photocells are doing? They are converting light energy into electrical energy. For what is A option? Change in the frequency of light into a change in the electric current. No. Change in the frequency of light into change in electric voltage. No. Change in the intensity of illumination into a change of photoelectric current. Yes. Photoelectric current only depends upon intensity. So we are going with C option. Next, it is from 2007 AIPMT. A 5-watt source emits monochromatic light of wavelength 5000 angstrom. When placed 0.5 meter away, it liberates photoelectrons from a photosensitive metal surface. When the source is moved to a distance of 1 meter, the number of photoelectrons liberated will be. They asked this problem in 2007 AIPMT. Again, what we are using? 5-watt source we have. Throwing a light of 5000 angstrom. Yes. When placed 0.5 meter away. Now same source we are putting at a distance of 1 meter. What you are doing? Only changing the distance, and you know that intensity is inversely proportional to distance square. Means intensity is equals to some constant upon d square. Previously Distance was 0.5 meter, means 1 by 2. 1 by 2 square means 1 by 4. So I1 was 4k. Now you make it 1. So now it is k. Means 1 upon 4 of 4k. Means 1/4 of the previous value. So what you did there, you make intensity 1/4. So now 1/4 photons are moving toward the metallic surface, so they can eject only 1/4 electrons. So photoelectron liberated will be reduced by a factor of 4. So we will go with option D. 18th. It is from 2009. AIPMT, the number of photoelectrons emitted for light of a frequency nu higher than the threshold frequency nu naught is proportional to, we know that number of photoelectrons depends upon intensity of light and energy of photoelectron depends upon frequency of light. So number of photoelectrons, it should be directly proportional to intensity of light. So we are going with option B. They asked this in 2009. Next, it is from 1988 AIPMT. The threshold frequency for photoelectric effect on sodium corresponds to a wavelength of 5000 angstrom. Means they are giving you threshold wavelength 5000 angstrom, not SI unit. So we have to multiply with 10 to the power minus 10. Now it is in meter. We want to calculate work function, means phi naught. It is hc upon lambda naught. H and c are well known constants. One is Planck's constant and second one is speed of light in vacuum. So what we are getting, table of 5 is not a tough task. One easy calculation we can do, multiply numerator and denominator by 2. Now no need for division. You will get only zeros in denominator. 6 table is not a tough table for you. 6 3s are 18. 6 6 are 36 and 1 37. 6 6 are 36 and 3 39. Decimal after 2 please. What is the power of 10? In denominator it will become 10,000. Means 4 zeros. When you will take them in numerator, you will get minus 4. So minus 38 and plus 8. Minus 38 and plus 8. Now lambda, okay, we forget this 10 to the power minus 10. It is also in denominator minus 10. So what in denominator? 10 to the power minus 10 and 4. It is minus 6. Take in numerator, it will become plus 6. So 14 plus and 34 minus, it means minus 20. But if you are using decimal, it should be after 1 please. So free 110 from this, it will become minus 19. We are doing in SI units, so unit should be joule. 3.9 means nearly 4 into 10 to the power minus 19 joule. So we will go with option A. Again, it is from 1989 AIPMT. Ultraviolet radiation of 6.2 electron volt falls on an aluminium surface. The kinetic energy of the fastest electron emitted is, work function is given 4.2 electron volt. I told you, when you are sending a photon of energy h nu towards a metal surface, it will divide in two parts. One part is taking electron on surface, it is work function. It is work function. It is total energy which you are sending towards metal. Plus half mv square. Remaining will supply energy to the electron. It is the kinetic energy of fastest moving electron. We want to calculate this in this problem. So what we are getting? Kinetic energy of fastest electron is h nu minus h nu naught. It is given in electron volt. You send 6.2 electron volt radiation. He used 4.2 as a work function. It is electron volt. So electron will come out with an energy of 2 electron volt. But all options are in joule. So we are converting this into joule by multiplying the charge of electron. So what we are getting? 3.2 into 10 to the power minus 19 joules. So we will go with option B. We will go with option B. Next, it is from 1991 AIPMT. A photoelectric work function of a metal is 1 electron volt. Light of wavelength lambda 3000 angstrom falls on it. The photoelectrons come out with a maximum velocity. Now we want to calculate velocity. Again, formula is same. If you are sending this photon towards metal, it will divide in two parts. This part will take electron up to surface. Remaining will supply kinetic energy. So first we will calculate the kinetic energy of ejected electron with the help of energy which you send towards metal, which it used by metal to eject an electron up to surface. So photoelectric work function of a metal is 1 electron volt. What is given? We write here, we calculate here. What was h nu naught work function? 1 electron volt. We will do in SI unit only because options are in SI unit. So 1.6 into 10 to the power minus 19 joule. This photon was sent by you towards the metal surface. Now it was minimum energy which he need to eject electron, work function, and you send the light of wavelength 3000. So now we will calculate energy sent by you towards the surface. H nu means hc upon lambda. H is 6.63 10 to the power minus 34 into 3 into 10 to the power 8 by 3000. Angstrom means into 10 to the power minus 10 meter. So what energy you sent? We are calculating that. Cancel this 3 with this 3. Now only zeros are in denominator. So number is that only 6.63 into 10 to the power. It is minus 7 in denominator. In numerator it will become plus 7. 7 and 8, 15. Minus 34 and 15. It is minus 19 joule. So it means kinetic energy of fastest moving electron, it is 6.63 into 10 to the power minus 19 joule. But we want to calculate velocity. So first we will calculate square of velocity. So it is 6.63 10 to the power minus 19 into 2 divided by m. M means mass of electron. 9.1 means nearly 9 into 10 to the power minus 31 kg. So 6.63 into 2, it is 13.26 divided by 9 into 10 to the power minus 31 become plus 31 and minus 19, it is 12. So what we are getting, 13.246 by 9, it is nearly 1.36 into 10 to the power 12. So what you will get V, nearly, it is 1 point something, not given there. So we are taking square root of this 10 to the power 12, you will get nearly 10 to the power 6 meter per second. So we will go with option D. We will go with option D. 21st, photoelectric work function of a metal is 1 electron volt. Light of wavelength 3000 angstrom falls on it. The photoelectric electrons come out with a maximum velocity 10 to the power 6 meter per second. So it was very simple, not a tough, only little bit calculation was there. Now next one. The cathode of a photoelectric cell is changed such that the work function changes from phi1 to phi2. If the current before and after the change are I1 and I2, all other conditions remaining unchanged, then what will happen? What is work function? Work function means minimum energy required to electron up to the surface. Remaining it will use as a kinetic energy. If you are increasing the work function, it means now electrons will come with low energy. But if intensity of incident light is the same, current will not change, photoelectric current will not change, because same intensity of light, same photons you are sending towards the metal surface. So number of photoelectrons which are coming out, that number will be same, but if you increase the work function, they will come with low energy now. So it means we should go with A option, I1 should be equal to I2. 23rd, it is from 1993 AIPMT, when light of wavelength 300 nanometer falls on a photoelectric emitter, photoelectrons are liberated. For another emitter, light of 600 nanometer is sufficient for creating photo emission. What is the ratio of the work function of the two ammeters? See, if you have two ammeters, you know that work function. For first, H is constant. So for first we are taking this. For second, work function is different using dash. H should be same because it is a constant. Different means nu naught should be different. But what is nu naught? We can write it C upon lambda. And for this, C is again same speed of light. Lambda should be different for this. We want to the ratio of work function phi naught by phi naught dash means HC by lambda naught divided by this or into cancel this with this. What you will get? Lambda dash 0 by lambda 0, and lambda dash 0 is 600 nanometer. Initially it was 300 nanometer. So what we are getting? 2:1. So we will go with option B, 2:1. So 23rd B.